Hello everyone, my name is Muskan. I'm currently pursuing my bachelor's from Sri Venkateswara College of Engineering in Computer Science Cybersecurity. Today I'm going to present on the topic F distribution. In this video, we'll learn about the definition of F distribution, its characteristics, some fun facts, some density plots, and its relationship with other distribution. And at the end, we'll take an example. So, the F distribution, named after Sir Ronald Fisher, is a probability distribution used in statistical hypothesis testing. It arises in the analysis of variance and compares variances of two or more samples. It is characterized by 2 degrees of freedom parameters. In simple terms, the F distribution is like a tool in statistics that helps us figure out if the differences we see between the groups are real or just random. It's commonly used to decide if the variations we observe are significant or just happen to be there by chance. So the definition of F distribution is that if x and y are two independent chi-square variates with nu1 and nu2 degrees of freedom, respectively, then F statistics is defined by F is equals to x by nu1 whole divided by y by nu2. It follows Nekedorf's F distribution with degree of freedom with probability density function given as below. Let's see the characteristics. So the F distribution is characterized by 2 key parameters, degree of freedom and probability density function. The F distribution has 2 degrees of freedom, usually denoted by df1 and df2. In tests like ANOVA, analysis of variance, df1 relates to differences between groups and df2 relates to the variations within groups. These parameters help us assess statistical significance. Probability density function, on the other hand, is a formula that defines how the values are distributed in the F distribution. The PDF depends on the degree of freedom and used to calculate probabilities associated with specific F values. Let's see some fun facts about F distribution. So this is a curve which has an F value, and the curve is not symmetrical. We can see that it is skewed towards the right. So the skewness decreases with the increase of the value of nu1 and nu2. The F statistics is greater than or equal to 0. Since the variances are squares, so the F value always lies in between 0 and infinity. It is always positive. Okay. Shape of F distribution depends on the number of degree of freedom. As the degree of freedom for the numerator and for the denominator gets larger, the curve approximates to normal. So since the value becomes more larger, the curve just becomes a normal distribution. Let's see some density plots. Plot 1, increasing the first parameters. As you know, there are 2 parameters. So let's see by increasing the first one. So the blue line here is the probability density function of F random variable with the parameters n1 as 4 and n2 equals to 4. And the orange line in the probability density function of the F random variable with parameters n1 is equals to 20 and n2 is equals to 4. So by increasing the first parameter from n1 is equals to 4 to 20, the mean of the distribution does not change. The vertical line here does not change. But the part of the density is shifted from the tails to the center of the distribution. Let's see the plot 2 where we are increasing the second parameter. So the blue line of the density of F distribution with parameters n1 is equals to 4 and n2 is equals to 4. This time, instead of increasing the first parameters, we'll increase the second one from 4 to 20. So by increasing the second parameter from 4 to 20, the mean of the distribution decreases. it decreases from 2 to 1.11. And some density is shifted from the tails towards the center of the distribution. As we can observe, the blue line here, after changing, is shifted towards the left, towards the center of the distribution from the right side. Let's see what happens when we increase both the parameters. Here, the blue line is the the first case where we're taking n1 is equals to 4 and n2 is equals to 4. And the orange line is the density of an f random variable with parameters n1 is equals to 20 and n2 is equals to 20. So in plot 1, we increased the n1 by 20 and n2 was 4. And in plot 2, we did the opposite. The n2 was 4 and the n1 was 20. So in this one, we are going to increase both to 20. So by increasing both the parameters, the mean of the distribution decreases and the density is shifted from the tails of the center to the center of the distribution. The distribution here has the bell shape similar to normal distribution. Let's see the relationship of F distribution with other distributions. Okay. The F distribution's link to the chi-square distribution is foundational. It emerges as the ratio of two independent chi-square distributed random variables. This relationship is pivotal as it lays the groundwork for understanding variability between sample means in different groups, forming the backbone of statistical analysis like ANOVA and regression. So this graph here is regression analysis, and here we can see the ANOVA. The F distribution serves as the linchpin in statistical inference. It intertwines with other essential distributions such as the normal and T distributions, enabling hypothesis testing and the construction of confidence intervals in various scenarios. Its application in ANOVA and regression analysis underscores the significance in drawing reliable conclusions from data variations. So in this diagram, we can see the variance within the group and the variance between the groups. So this is the variance within the group for the blue curve, and this is the variance between the groups from blue to the green curve. Moving forward, let's take an example. An example of F distribution can be found in analysis of variance, considering comparing the variances of three different teaching methods. The F static, calculated as the ratio of variances between the methods, follows an F distribution. The higher F value may suggest the significant difference in teaching effectiveness. Conclusion. In summary, the F distribution is a vital tool for understanding differences in data. It helps in ANOVA, regression analysis, and hypothesis testing, guiding decisions in various fields from medicine to social sciences. Mastering the F distribution unlocks the ability to interpret data variations effectively, making it essential asset in drawing meaningful conclusions. Thank you. Please like, share, and subscribe.